Right, after making some notes, I'm back. So, let's start with some quotes, right? And because everybody wants some motivation, so well, here it is. Technically, chemistry is the study of matter, but I prefer to see it as the study of change. Electrons change their energy levels, molecules change their bonds, elements change into compound. But that's all life, right? It's constant cycle of solution, dissolution, just over and over again. It's the growth and then decay and then transformation. It's fascinating, really. Walter White said this, and I just simply respect chemistry. I hope this gives a bit of motivation. If not, just watch Breaking Bad. You will get automatic motivation of studying chemistry. Alright. So we will come to this later. But here we are. First of all, NCERT book. Yes. We studied this, but I'll just revise it for you, just in some few simple things. Alright. Chemical reaction and equations. Change. What are changes? Changes are anything with change, like this. If I move this is a change. But in here, it is supposed to be a change, which is a change which is, well, big enough. You can't write moving a pen as a change in your exam, of course not. So physical changes are usually reversible, like tearing of paper. You can't reverse that, but it could be, for example, drying of making of dry ice, and then just heating the dry ice so that it becomes CO2 again. Then there are chemical changes which are mostly irreversible. It could contain burning of wood. Then some chemical reactions like methane plus oxygen gives off CO2 plus water plus energy. This is an example of chemical change, irreversible. This, as you can see. And we will get into one more equation after I finish today's lesson. Now, how do we know there was a chemical change? First of all, chemical change is basically a change where the chemical composition of a substance changes. It could contain we could only know if there is a chemical change when there is a change in state, change in color, evolution of gas, change in temperature. Alright. Now, change in state. Change in state is, for example, hydrogen and oxygen are gases, but when they combine, they give off water. Don't try this. It's hydrogen is explosive. That's the reason we can't just produce water out of the air. And then there is carbon plus sulfur equal to carbon disulfide. Well, this is also a change in state. As you can see, S stands for solid, G stands for gas. So solids are changing into gases. Then there is here we have potassium iodide with lead nitrate, which gives off potassium nitrate plus lead iodide. This we have yellow plus transparent gives off yellow PPT, which is precipitate. I will introduce you to these terms later on this chapter. We have already discussed change in state, change in temperature. Here we have some examples. For example, CaO, which is quicklime plus water, gives off calcium, calcium what slag lime. Yeah, slag lime. Um, which gives off heat. This is very this has too much heat. We will come to this later because this is also an activity. Then we go to some normal questions which would help understand this chapter very much. What are chemical equations? Now we are getting into the world of chemical equations, which introduce us to calculation of equations. But let's see what's chemical equation. Chemical equation are as you can see, there are as we have learned that magnesium, hydrogen, oxygen, lithium, beryllium, fluorine, argon, neon, such are elements, right? So which we are just showing an experiment or an reaction, chemical reaction, mostly chemical reaction. Yes, which is only chemical reactions. There, it is called a chemical equation for a reason. But chemical reaction is represented in their chemical formulae. How? Well, it is quite long to write. Magnesium plus oxygen gives off magnesium oxide. Now let's this would be given in your question. You have but we usually write it like these in symbols, like C stands for carbon, oxygen stands for O stands for oxygen, and CO2 stands for carbon dioxide. How do we write a chemical equation? First of all, we write the reactants or which are being combined or displaced or anything like that, but we just write those elements which are being reacted with each other to give a product or give products. Like we have magnesium and oxygen here, which are our LHS or reactants. Here we have our RHS or product, which is magnesium oxide. The equation for this would be Mg plus O2 equal to 2MgO. But you would have noticed something here. Wait a sec. Yes, as I was saying, you have noticed something here. The number of atoms here are not equal to the atoms here. Isn't that right? So what we do is magnesium plus O2 gives off MgO. What's this? O2, right? Where's that O2? Well, this introduces us to the world of balancing equations. To balance this equation in specific, we will write 2Mg plus O2 equals to 2MgO. Now O2, O into 2, O2 equal 2Mg equals to 2Mg equal. I did that directly because I have only some practice right now, but I know the basic chemistry. Not the basic chemistry, but like this beginner's chemistry. Now, what is balancing equation? Changing of numbers of atoms or molecules of reactants and products of elements so that the number of atom in reactants and products is the same. As I showed here, the number of atoms in reactant or the left hand side and product or the right hand side is the same. This is due to the law and this is done due to the law of conservation of mass holds true. Now, what was the law of conservation of mass? Comment below, but I'll wait in 3 seconds. Alright, just pause the video. Alright, I'll just go with it. Law of conservation of mass was, energy or mass cannot be created or destroyed, which, let me just show it on my book real quick. Where's that? Wait. Yes, this. Alright. Mass can neither be created nor destroyed in a chemical reaction. We studied this in 9th. So how do I balance an equation? First, let's start with the basics. We have let's take the simplest one yet, which is, this 2 mg plus O2, mg plus O2 O is equal to 2 mg. Is this balanced? No, this is not balanced. If without these twos, it's not balanced. Let's just take a more complex to start. Alright, zinc, which is Zn, plus sulfuric acid, which is H2SO4, I believe, gives off zinc sulfate plus H2. Is that not right? Let's check. Alright, yes. Now, to balance this, what will we do? First, we will draw these squares. Excuse that bell. What does these squares even represent? Well, they are to signify that you cannot change the elements. You cannot change how the elements look or where. Like, you can't just change zinc into iodine or zinc into uranium-235. You can't. Of course you can't. You have to only change the number of molecules here. Not these. You cannot change these. These are immortal enemy object. Alright, so zinc, one atom of zinc, one molecule of zinc plus one molecule of zinc equal LHS equal to RHS. So first, let's first step is to write the elements. Sorry for that, capital N. Hydrogen, sulfur, oxygen. Now zinc in the left hand side is 1, hydrogen is 2, so sulfur is 1, oxygen is 4. You write elements here. I am not writing because no space. And reactants and products. Let me just write R and P here. Alright. On the product side, we have zinc, which is 1 atom, 1 molecule, sulfur, which is 1 molecule, oxygen 4 molecule, hydrogen 2 molecules. Here we can see LHS equals to RHS. Yes. But if we were to take a very not balanced equation, for example, let's take the first one here, which is this iron plus water. Iron is Fe plus water, which is H2O, gives off ferric oxide, which is ferric oxide, or it is also called iron second third oxide. Remember that these short notes are actually very important, they add up. So we give this and then ferric oxide. So Fe3O4, I think. Is it 4? Yeah, plus hydrogen. Now this is clearly imbalanced. Why? Let's make a table here. You always make these tables. I am making them unneatly, but you need to in each step you need to write these. But first let's make these boxes. Ferrous, water, ferric oxide, hydrogen. Now let's see, ferrous or iron, hydrogen, oxygen. Anything else you can see? Ferrous, hydrogen, oxygen, ferrous, oxygen, hydrogen. Alright. Now these are the elements. These will be the reactants and the products. So ferrous 1, hydrogen 2, oxygen 1. Now on the right hand side, or the products, we see ferrous, which is 3, oxygen, which is 4, hydrogen, which is I messed up there, hydrogen, which is 2. What's balanced? We can see hydrogen LHS equals to RHS, but in these we don't see it. It's always convenient to start with the most differentiated one, like with the highest one, or yes. So let's do first oxygen. So oxygen, on the left hand side it's 1, and on the right hand side it's 4. To balance this, we will just Fe plus 4 H2O. This 4 is multiplied by this and this, so we will get 4 into 2 hydrogen, 4 into 1, which is 1 atom of oxygen, which 4 into 1 molecule, which is 1, gives off this ferric oxide plus hydrogen 2. Alright, what we do now we make this table again. It's very important to make these tables. Alright, these carry marks. Ferrous, hydrogen, oxygen. Ferrous now is 1, 3. Hydrogen 4 into 2 atom molecules of hydrogen, which is 2 into 4, 4, which is 6, and here are only 2. 4 into O is 4, and here is 4. Now what we see? 6, 2, not balanced, and ferrous. So one change at a time. Ferrous plus 4H2O gives off Fe 3 plus O4, Fe4 O4 plus H 2 into what would be 6? 3H2. Now we make this table again for the last time. Ferrous, second last time. Ferrous, hydrogen, oxygen, 1 3 1 3 6 6 4 4. Last change, ferrous 1 molecule, ferrous 3 molecules. What we do, add 3 more atoms or molecules of this. 4H2O gives off ferric oxide plus 3H2. This would be our final equation, and this will be, now we change this to 3, so LHS is equal to RHS. Therefore this is now balanced, as the molecules on the LHS and RHS is determined by this arrow. On the left hand side of the arrow there would be reactants, right hand side of the arrow there would be products. Left hand side is LHS, right hand side is RHS. So atoms are now equal, atoms or molecules are now equal, therefore this chemical equation is balanced. I will end this video for now. Next time we will be looking into more balancing and some activities. There would be 3 more activities which I will show. Thank you for being here, and subscribe so people see this, and I guess that's only what can I say. Never stop